Hi everyone, welcome to the fourth day of base SAS. Till now we have seen that how to work with base SAS software, how you can import data from a raw text file, from an Excel file, and how can you create a data set and how can you create sub data sets from an existing data set. We have gone through various SAS libraries which I shown you. When I say libraries, means we have already worked with SAS help, SAS user, we have a work library, and we have created our own library. So we have already seen that how we work with a lot of objects in SAS software. Today what we are going to cover is about input buffer, PDV, and how we can compile and execute our code in SAS. So I know that input buffer and PDV are new terms to know, but we'll be going through all these and we'll discuss how exactly these impact our day-to-day working with SAS software and base SAS. So let's get started. All right. So all of you know, like when we write a SAS program, what exactly happens? Let's say I'll talk about just a simple thing. Right, let me go to the SAS helps, and here you can see that we have a lot of data sets. So I'll just write a simple program, let's say data, and I'll give it a name and I'll try to save that in work.air, and then I'll say set SAS help.air. I'll say run. So it's very simple program, and you know that what I'm going to do here is I'm trying to create another data set called work, and wherein I'll be what I'll be doing, I will just create a simple copy of SAS help.air into work library with the same name called air. So as soon as I run this program, you go to the log window and you can see. All right. So what you can see here is that we have got the warning, though it says that there were 144 observation read from the dataset SAS help.air. The dataset work.air has 144 observation and two variables. Data statement use totals process time, the real time, and CPU time. So it gave you the complete information that a dataset been created. But do you know exactly that what happens when you write such a program? Right? There are two steps in which or after that this program gets completed, right? So this is what this slide is talking about, that whatever program you write or whatever data step you write in SAS or base SAS, what happens? The data step gets processed into two phases. The first phase is compilation and another is execution. So when I say compilation, compilation is nothing but whatever code we have written, as it happens in every programming language. First of all, whatever code you write, that gets compiled, and the second step happens that it gets executed. Right? So in same way, whenever we write the SAS program, it gets compiled. First of all, in the first phase, it gets compiled, and in the second phase, whatever code is compiled, it gets executed, right? So it may happen that sometimes we get some error in the compilation phase as well. So in compilation phase, whatever errors we get in compilation phases, those are basically nothing but syntactical error, right? So if there is any syntactical error, that will get caught in compilation phase only, and that shows that there is a problem, or your program, whatever program you have written, that's not correct. So if you get any error in compilation phase, that shows that the program which you have written is not written in a correct order. But like sometimes you get errors in execution phase, right? That shows you program whatever program you have written, the SAS code you have written, that is correct. But if you still got a problem or the error in execution phase, so those are basically because of the data, right? So because of the data, whatever error you get, that happens in execution phase. But due to programmatical error, syntaxical error, whatever error or warning you get in compilation phase, that shows that your program is not correct, right? So it says that under SAS help, under the heading data step processing, the complete flowchart is given on what happens on backend when the data step is processed, right? Now it says that compilation phase. During the compilation phase, SAS checks the syntax of data step statements, as I already told you. Then it creates an input buffer. So you remember in the topic I said that we'll be talking about input buffer, then we'll talk about PDV. So here is the term called input buffer to hold the current data file record that is being processed. And then SAS creates a program data vector. This is nothing but the PDV to hold the current SAS observation. Observation means a record or row. Then it creates the descriptor portion of the output dataset, right? So let's talk in detail about this compilation phase, right? So during the compilation phase, SAS checks the syntax of the data step statement. So this is the first step what SAS base does, that it checks for each and every syntax whatever you have written in your program. It checks for that, validates whether the program which you have written is correct or not, right? Now I'm specifically talking about the data step right now because the first slide is about the data step. So we are going to work on the data step right now, and I'm talking about the compilation phase. That in first step, it checks for the syntax or the program, whatever you have written. The number two, it creates an input buffer to hold the current data file record that is being processed. So now let me tell you, let me just go back to the SAS system here, and I'll click on this A dataset. It's going to open the file of the A dataset. Now here you can see that we have two variables, date, and another is international air travel, that is in 1000. Okay. In date we have a date in MMMDD format, and then we have international air travel in 1000. That may be the amount. Let me column attribute. I have just double clicked on it. It says no, it does not have. Okay, its name is air. Okay, so I guess this may be the distance, or this may be the the amount in dollar or thousand. I'm not sure what exactly it is, but yes, we have two variables here and number of observation. When I say number of observation, means we have in total 144 observation in the dataset. So let us say the program which I have written here, that is going to replicate the same data set into the work library. And this is exactly what the program I have written. Now you can see that I have written data work.air and then set SAS help.air. So from this, I have set a data set called air from the SAS help, and it's gonna replicate the same data set into the work library. Okay. Now what actually happens in the backend? Whenever we will run this program, first of all, as a first step, according to the slide, that SAS program is gonna check the syntax whatever I have written. So once if it will validate the each and every syntax of the program what I have written, if that is good to go, then SAS will go to the next step. And what is the next step is, as per the slide, that it checks it creates an input buffer to hold the current data file record that is being processed. So what happens, the data set which we have here, SAS selects each row one by one. So in a one go it processes it processes one row. And for each variable, it creates an input buffer. It means it allocates that data, that record into the temporary, I would say, yeah, input buffer is nothing but a temporary memory allocation which happens in the backend. Okay, so it allocates each record with a temporary memory allocation, or what it does that it allocates that record into the temporary memory of SAS for the time being, right? Once it creates or it allocates that in the memory, that record into the memory, once that record is fulfilled, that complete record gets shifted into the another destination, like in the work.air. Okay, so let me just open a Excel here so that I can tell you in detail that what exactly happens in the backend. Okay, just give it a minute. Let the Excel be open in my system. We call it what happens in the black box. Now, black box is nothing but the backend of SAS system. Okay, here we go. So let's say we have two variables A and B, and we have number of records. Here we go. These are the variables, and we have number of observations here. So whenever I will try to create duplicate or replica of this data set into the SAS space, so what will happen? Let me do the see. Okay, we have 4 observation. So what SAS will do, as soon as I will write the similar kind of code with whatever I have written here, the data work.air, then SAS help.air. So what it will do, first of all, it will it will observe that what type of variable I have, if it is a character or if it is a numerical. It will similar kind of, depending on those data types, it will create an input buffer. Okay, that will be in the backend. It will create for A and for B similar kind of variables. It will allocate the space for these variables into the memory of SAS, or not exactly memory of SAS, the system, okay, in the backend. And first of all, it will create the spaces, and then it will fill the values one by one. And as soon as this step is complete, what it will do, it will shift these values into the destination what I have given to the SAS. When I say destination, means in my case that is a work library, right? This is the first step what it does. In the first go, it will do this process. Now the iteration goes back to the second serial number, and then it picks the next two values. It overwrites the original ones, not basically overwrites, it deletes them from the input buffer, and then fits it into the same input buffer or the memory allocation what is happening for the temporary okay. And then all right, so as soon as it gets Alright, so as soon as the first record gets shifted to the destination, just after that, as I already said, that it works record by record, right? So as soon as you can see that first record got shifted to the destination, like the second record, the counter or the pointer goes to the second record, and the input buffer which was created for the first record got emptied, and then the values for the second record get shifted into that input buffer. Okay, once the record is completed here, how is basically it happens? It happens for each variable at a time, right? First of all, the value for variable A will be shifted here, and then the value for variable B will shift here. And as soon as both the complete row got shifted, the complete row gets shifted to the destination, and again it will get emptied, right? Now next, the pointer goes to the third row, and then it will shift the values to the input buffer. So similarly, one by one, like each record gets shifted to the destination via input buffer, right? Like how it works, basically this information, so what happens that each line is processed in order from top to bottom. So when I say top to bottom, so like first of all, the serial number 1, it will start from serial number 1 or the observation number 1 to observation 4, and then top to bottom means first of all a variable A will be shifted and then variable B will be shifted. So similarly, one by one, by shifting values from each variable into input buffer, and then from input buffer to the memory, it gets shifted to the destination, right? This input buffer is nothing but called PDV, right? So PDV is program data vector. Okay, this is just a called program data vector, but again this is the same thing where it saves the input buffer for the intermediate period or time period, right? And at the end it creates the descriptor portion of the output. So descriptor portion, I told you in the beginning that what basically descriptor portion is. In order to see that again, we can go back to the SAS environment, and I will just write another proc, let's say proc data, and then I will say data is equal to work dot air, sorry, proc, I need to give the name of proc, that is proc content, and I will say run. And as soon as I will run this proc, you will see the output. Okay, something went wrong here. Let me close it, and I need to go to the log window, and let's see. It says that procedure, okay, content. It's a contents. Proc contents. Now it's showing me running. Let's see that what happens in a minute. As soon as the complete proc will run, you will get some output. And what basically I want to show that. It will open another window with the results. Now here you can say this is the proc contents, and what it is telling you about that what is the name of data set, what member type of this data is, how many variables are there, how many observations are there, indexes, is there any index, observation length, is it compressed or not, when what is the date when it was created, what is the data representation, right? So it is a complete information about the data set. So proc contents give you the information about the data set, and this is nothing but the descriptor portion of data set. So I have already told you in some other session that there are two parts of data sets are there. Number one, the data, and number two, the descriptor portion. So data portion has the actual data for a data set, but the descriptor portion has the information about the data, or you can say the metadata. So what happens once the PDV is created, it creates the descriptor portion of the data. Okay, so that is the last step for the compilation. We have finished till here. We have finished the compilation phase of a data step, and as we move to the next step, which is called execution. So what happens in execution? That iteratively inputs the individual records. As I already told that it works from top to bottom. In case of data error, it writes an error message to the log and continues to the next record, right? So if you get an error in compilation phase, your program will not at all run. because there is a programmatical error. But if there is a data error, then definitely for that particular record or for particular observation, your program may not run, but it will, as soon as the iteration will move to the next record, it will run successfully. So the execution do not or does not stop till all the records are read. However, if there are mistakes in the record, that will appear confusing, and there would be, the log would be created for them, right? Under files, we have a raw data file called revenue2. Let's read the data using the in file and input statement similar to what we did last time. See what answer we get. Okay. So data revenue2, let me just search for this data content. So revenue2, you can see here, this is the data revenue2. And this is the data which we have here in the file. Okay. It has the location name, then freight, then direct. So just give it a minute, and I'm going to just shift it to the, or move the data to the SAS. Just give it a minute. Okay. So I'll be writing the same program here as we have in the PPT. So let me just close this file, and I'll go back to my slide. This is the program which I really want to write. Data revenue2. Okay. Before writing this, what I can do is I will create another location where I'll be saving my the data set which I'm going to create. So let's say in this folder only, I will create another folder and I'll give it a name called Satya. And now I can create a library with this name. So I need to go to the here. I will write lib name. I will give it a name called Satya2, or I can say it Satya, and then I need to give the location name. And as soon as I will run this, it will create a library name for me. So I'll go to the log, and it says that was successfully assigned as follows. So if I go here in the Explorer, you can see this Satya has already been assigned. Now whatever a data set I'm going to create now, let's say Satya dot revenue2, and now this is the time where you need to concentrate that how I'm going to import the data of this text file, the revenue2, into SAS. Okay, now just imagine this text file here and the code which is written here in the SAS environment. Then it says data satya.revenue2. Satya.revenue2, this is the second level of name. It means the first name is the library and the second name is the name of the data set which I have given here. Then length hub $15. So hub is nothing but the location. So like Frankfurt or London, that is the name of hub. $15, it is the format. If you remember the session which I took about format and end format, so the length regarding any variable is given after the $sign. So this is what I have done. Like I have given the length as 15 for hub. The another thing is freight. So I have given a length of 15 again to source. Then type, is it direct or indirect or other? So the length is 10. And then revenue, what was the amount of revenue which was generated? So for that I have given length as 8. So first of all, I have given length. I can define the format in this way, or for each variable I can decide the variable later, the format later on as well. Now after that I need to give the location where my file is located. So for that I need to go to the location. This is the location where my file is saved. I'll go back to SAS system. I'll change this location. I'll change it here only. Now then I need to give it in double quotes. And then DLM. DLM is nothing but the delimiter which I have used. So you can see into the file, the text file. there it is comma separated. So that is why delimiter is nothing but the comma. Okay. And then input variables, the name of variables like hub, source, type, and revenue. As soon as I will run this statement, you can see that the revenue too got created here in the contents of Satya. So if I double click on it, you can see the same kind of data set would have been created here. But unfortunately, we don't have the revenue values. You can see that I don't have revenue values. I am getting missing all across. Okay. You may know it because the value which I had here, when I was giving the program, writing the program, I have given it as a revenue, and I didn't say that it is var character. So it by default took as a numerical value, but the data which I had was formatted as in dollar. So that is why it didn't import that, and there is an error. What I can do is that I can try to import this in form of character. Let's see that what it's gonna do now. It will override the existing data set. I have double click here, and now you can see some of the values. So this is how basically it creates. But again, you can see that my values were comma separated. So that is why you're not getting the full value here. We will look for the other provisions how to import this delimited value. But right now what I'm going to do is I wanted to show you that how this PDV and input buffer works here in this situation. So you can see here the same situation what we were talking about, that when we imported this data, everything works fine except the last column. Now the reason that SAS by default using the in file and input statement can read only standard numeric data, but the data which was there in the file is not standard, right? It is formatted, so it is non-standard data. And if it is not a standard data, then data with the dollar sign in the column is non-standard numeric data. And by default, when there is a missing data at the end of the row, SAS does not the following. So basically you can see if it is non-standard, SAS will not assume it as the required format and it will treat as a missing. So that is why in the first case when I didn't use the dollar sign here, I'll go back with the same again. I'll run this program and this time I will write proc print data is equal to Satya dot revenue 2 and run. So as soon as I'll be running this, you can see the data is everything right, all right, except the last column, because all across you can see the missing value in the last column. Okay, so this is exactly what he was talking about. So such a situation where it misses the last column. Okay, we will exactly not this, because here the reason was that it was the formatted data. So that is why it didn't accept any value. But by default, when there is a missing data at the end of the row, suppose that there had it been that you didn't have data in the last column, so it would have loaded the next record to finish the observation or writes a note to the log. So the miss over option prevents SAS from loading a new record when the end of the current record is reached. Okay, so this is exactly what happens in case of miss over. In file path, file name is over. If SAS reaches the end of the row without finding any value for all fields, variable without the values are set to missing. What happens to the backend, right? This is exactly what we were talking about. But let's see, let's take an example of miss over first. So when I say example of miss over, let me write a data lines. Let's say I will write data, then I would write Satya dot test, and here I will write input, and I'll take variables as, let's say, name No, I will not take name. Let's say I will say A, B, C, three variables, and then I will say data lines. For A, let's say 1, then 2. Here I will say 3. Here I will take 5, no, 5, 6. Here I will take only 3, then 5, then 6, comma 7, comma 8. Let's say 7, comma 8, comma 9. And then again 9, comma 0. And then 1. Okay. I'm going to run this program and you need to observe that what exactly SAS is going to do, right? So I'll say later on after this I will write proc print data is equal to satya dot test and run. Okay, you can see here this is the basic difference which I wanted to show. Yes, look at this data now. What is happening? Like, first of all, I gave three values for all the variables like A, B, and C. So it's A is equal to 1, B is equal to 2, and C is equal to 5. We got the values for all variables. Then similarly, the same thing happened for the third row as well. So the second row, that's 2, 5, 6. But for the third record, we have 3, 5. But for C, we don't have any value in third record. So what SAS did, it went through that, it filled that values like 3 and 5. And then we have got 6 here. Where it gets the 6 from? It got the 6 from the third value, right? Sorry, from the next row, 6. And then after that, it skipped 7 and 8. We don't have the 7 and 8 in the data set. It frequently, directly moved to the next row. I told you while using the input buffer, if the record gets completed into the input buffer, the SAS pointer automatically moves to the next row. So if this 6 got shifted to the previous row, at this place, and the 7 and 8 got skipped. Now the SAS pointer starts from here, 7, 8, 9. So we have 7, 8, 9 here. And then again 9, 0 and 1. Had it been 5 here, it would have been skipped. So let me show you that once again. I'll run this program. And now you can see that we have 5 here, but that got skipped. We don't have that in the data. Now the situation comes if I use miss over here. As per the slide, you can see that if we use miss over with the help of using in file. So let's say I'm going to use miss over. I can use here in file data lines and then miss over. Let's see that what it's gonna do now. Okay, so this is the new result which I have got, but as soon as I have used miss over, you can see that the data which we have entered, like 1 to 5, we have 1 to 5, then we have 256, we have 256, then 3, 5 and then missing value in the input statement. Similarly, we have 3, 5 and then the missing value in the result. So by using miss over, we have overcome this challenge where there was no value for a particular variable. Similarly, we are getting a missing value in the data set. So what I was about to talk, that if we, what happens in case of PDV, if suppose that we are not using misover, then automatically it uses the value from the next row at the place of missing value and skips the remaining values, right? I know that it may be a bit difficult to understand, but the main crux is here, right? It fills these three values for the input buffer. I'll show in Excel, right? Let's say that I have these values for A, B, and C. So as soon as we run this code, what it does is creates an input buffer for A, B, and C in PDV. Let's say this is the final destination and these are the input buffer. Let's take it as input buffer, and this is the final data set. Okay. Now, what happens in case of input buffer? So as soon as we run this program, this first values get shifted into the input buffer for A1, for B2, for C5. And as soon as these values get filled, that SAS identifies their descriptor portion. It shifts these values into the final data like this, and then it empties these values. Now for each input buffer or the location, they have the kind of data step or the data type they should have. Now it moves to the next row. It fills 2 for A, 5 for B, and 6 for C. Everything goes well. It shifts these values to the second row of final data, and then again empties these values, right? When it empties, it assigns a missing value in each field, right? Now what happens? It moves to the iteration moves to the third row. Now here what we have is that for A we have 3, for B we have 5, but for C we don't have anything. So it directly moves to the next row, which is 6, right? So it fills in the 6 here if we are not using misover. Okay. In case of no misover, it fills this situation, right? It moves these values to the final file, and then again it fills the missing value in case here. And we were here at this 6, right? The input buffer got filled, so the pointer moves to the next row. Then it skips these 6 and 7, it goes back to the next row, fills 7, 8, 9, and it works for the next iteration in the same way. But what happens in case, let me just run it for other rows as well. It then empties it. Then it moves to the next row. It fills the values like 9, 0, then 1 from the next row, and it fills these values into the final data set. So this way it creates the complete data set without misover, and we get the value for each variable. But what happens in case of misover if we use misover with the data lines? Right? So what will happen in case of misover? In first case, let me create like this. In first case, it will fill the 3 values like 1, 2, and 5. It will move them here, empty the value, move to the next row. It will fill 2, 5, 6. Input buffer gets filled in. It shifts the values to the final file. Then again it empties. It's a complete cycle which gets followed in every time. Now it moves to the third row, that 3, 5 it gets over there. So it will insert 3 and then 5. We are using miss over, so it will skip. It will accept missing value because it does not have third value for the third variable in third row. So it will just pick these values, accept these values, move to the next row, empty them again, missing, and then capture the third row, next row, that is 6, 7, 8. It will fill in 6, 7, 8. It gets completed. It will move to the data set, empty them, move to the next pointer, 7, 8, 9. 7, 8, 9. Follow the same process, frame cycle, moves the values to the data set, empty them here, and move to the next row. And again it will encounter only 9 and then 0. Nothing is there for the third variable, so it will treat that as missing, shift the values in the data set, and go back to the input buffer, then missing, release the memory, and then it will go to the last row and it will find only 1 and a 5, and then missing value for the third variable, and then it will shift these. And then finally, as if now like there is no record in the data set, the input buffer will get released. I mean, it will not hold any value. So by following with miss over and without miss over, these two type of data set got created. Now if you go back to the SAS data sets, the results which we had, you can compare. We would have similar kind of result. You can see here, this is the first without miss over. We have 1, 2, 5, 2, 5, 6, 3, 5, 6, 7, 8, 9, and 9, 0, 1. And this record set got created, or the result got created when we were using missing value or miss over. So you can see that we have 3 missing values, and rest the values which we have here in the data are exactly the same we planned for. So this is how the data set got created by using miss over and without miss over. But following exactly the PDV and the input buffer, that how SAS allocates the temporary input buffer and how it holds the values to pass to the final data set. Now what happens in the backend? We have already seen that what happens, but let's go through the slide. That when reading from a raw data file and reading from the SAS data set. So basically there is small difference, right? Reading the data file, SAS data file would be easier for SAS because it need not to create the descriptor portion again. But for when reading the data, raw data file, SAS need to create the descriptor portion again. Okay, so there is the major difference which is there between these two processes. Now consider two examples, the raw data file and the SAS data set. We have similar kind of function or the program written here. Let's move to the next file. When reading from the raw data file, the following is done in the backend by the statements. So just read that what is happening. In case of compilation phase, data checks. Now first of all, we are doing it from the raw data file, right? So it checks the syntax in the compilation phase, creates the new variable, defines the length of new variable, creates the input buffer, creates the PDV, and run creates the descriptor portion of the data set or output data set. So this is what all happens in compilation phase. And then in execution, data creates the data set, in file locate the path, input, it moves the raw data file to the input buffer, from it moves to the PDV, and then run implicitly output implicit return. Okay, so from input buffer it creates PDV, and then from PDV it creates the actual data set. So this is what all happen in case of raw data file. But when we process the same with help of from an existing data set, what is going to happen? Let's see that. So when reading from a SAS data set, the following is done in the backend by these statements. The data checks the syntax, right? Locates the input dataset, creates PDV, creates keep and drop flags or drop, create runs the descripted portion of the output dataset. So this is exactly what happened in case of raw data file. But in case of SAS dataset, what it happens that data initializes the PDV, sets the data transfer from input dataset to the PDV, keeps drop and run creates flags, and it automatically executes the program and create the final data set. So there is a, I would say, if I talk about the optimization view or the time saving, then definitely creating a data set from existing data set is easier, less resources are used, and it's easily created, right, in less time. Now question, when SAS reads from an Excel file and creates an output SAS dataset, what rules does it follow in the backend? Reading the data from raw data file, reading the SAS dataset, a completely different method. What do you think? Your answer would be depend on the understanding what you have done. But let me just tell you, it follows the first one, that reading data from the raw data file. But again, you need to think that why it is happening and why I said that it's the raw data file, not the SAS dataset or a complete different method. Okay, let's move. Another question may be that the 10 individuals who have family history of diabetes have their blood glucose tested at a local clinic. The value of postprandial glucose level and preprandial plasma glucose have been recorded in the file. This chapter 7_1 text. So let me see whether I have that file or not. Okay, I don't have that file right now. Okay, not a problem. We'll take another example. Okay, this is here. To read the raw data file containing standard values into SAS dataset, we use the following syntax. We have already done it and several times, and we have created several data sets by using such a example or the raw data or the data lines. Okay, in this case, the code is the following. This is the same code which I have, we saw in the previous slide, and they have created this data set. Okay, let's slightly talk about the delimiter, that what a delimiter is. That a space blank is a default delimiter in SAS. So you may remember that I was using just a space between these numbers. So that is default delimiter. I can use comma, I can use colon, I can use any special character, and I can specify that as delimiter, but space is a default delimiter in case of SAS. So a space blank is a default delimiter. The DLM option can be added in the in-file statement to specify an alternate delimiter. Okay, DLM is nothing but the delimiter. If apart from space you are using any other delimiter, comma, colon, or any other number, you can specify that. So the example is given here, that in-file path and file name, and then DLM is equal to, in quotes, you can give the delimiter. Like they have given comma here. So this is exactly, you can give the data like this. Okay, list input. This is the another way of inputting the data into SAS from the raw data file. That the method for inputting text data into, we just saw, is called list input, and the variable and values are input in the list, and they are all standard value. Recall that all standard values are values that SAS reads directly without any special instructions. We have done it multiple times, so there is nothing new for you. By default, the length of character variable would be 8. Point to be noted that by default, the length of character variable would be 8 bytes. In case we want to accommodate bigger values, we need to explicitly define the length of variable, and we talked it about in the formats that we can specify the length whatever we want, but by default SAS takes it as 8, right? Now the syntax here is given like length variable 1 and then length 1. So length 1, if you do not specify anything, it would automatically be 8. And if you are going to specify like 15 here, dollar and then 15, so it's gonna accommodate 15 byte space in the system. Okay. Our text file has the following dates in this format like MMDD YY format. How can you read this data? So I have already covered this in the previous sessions. You need to think about it, how and what in format or format you are going to use to import this data. This is the PDV we have already talked about. Let me show you that how you can see the PDV, basically how is that works. So I just need to give here as put underscore all underscore. Let's see whether it's working or not. Okay, I'll tell you that how exactly it works, but right now it's not working. Let me go back to the previous example here, this one. I just need to use this here. Okay, here you can see this is nothing but the PDV basically, right? It tells you the values for A, B, C, all three variables, and with that you have got three system defined variables like underscore error underscore and then underscore n underscore. Underscore n underscore is nothing but the observation or the iteration number. So we had 5 records, we have got 6 iterations, right? In case of error underscore, until unless it is 0, the because it is for each row or the observation, so it has only two values, 0 or 1. If it is underscore error underscore is 0, it means there is no error. If its value is 1, it means there is a error in that particular record. Its value cannot go more than 1. Okay, it will always be 0 or 1. 1 indicates that there is an error, 0 indicates that there is no error. Now rest that you have all missing values in PDV. So as I have already told you that when we use input buffer and PDV, so what basically happens that you by default you get missing values in the PDV because it gets reset after every iteration to the missing value, and this is exactly what you are getting in the PDV, right? So in order to see the PDV, nothing but you need to use put underscore all underscore in your program, and you will exactly get the PDV printed into the log window. So put is for to print into the log window, and all underscore all is for all the variables which are involved in the processing. So here we have all the variables. These are the two system defined variables, error underscore error and underscore n underscore, and these are the three variables which were there in my data. Okay, so 5 observations, 6 iterations and 0 errors, 3 variables. This is how my dataset got created. Now let's move to the next slide. Okay, let's go through this slide once more. That the PDB's temporary file is stored in the memory of a computer. It is like a transist. Whenever SAS datasets are created, the PDB works in the backend. The content of a PDB changes in every iteration and they can be viewed by entering the code. What is that code? That's put underscore all underscore. The content of a PDB when using put underscore all underscore are viewed in a log window. After the dataset is created, the PDB is deleted automatically, right? So when the dataset is created, first of all, the values are set to default, that is missing, and then the PDB is deleted automatically. So this is what when we created a dataset from the raw data file or the existing dataset. Let's see the another case is creating SAS datasets from existing SAS dataset. We have already seen that what functionality it uses in the backend, but let's see again. Both the processes would be involved, whether it is a compilation phase or execution phase. Compilation is every time used whenever we create new program, and then execution. This is what we have already seen. Okay, so in the compilation phase, check step 1 and step 2. You can go through and check it out. Okay, now compilation is over, we move to the execution. So basically, if I talk about here, you have the 4 observation, and that is why they have given the compilation step for each variable or each observation basically. Similarly, the compilation, we have already talked in detail that how it's gonna look like and what values you are going to see in the input buffer and PDB. If you want, you can go step by step. So let me go back to the log window once again. Whatever values you are looking at the slide right now, it's nothing but these values, right? How the values are being set to missing and how the error and underscore variables are getting. So you can see that automatic variable underscore error underscore and underscore n underscore are dropped from the output dataset. Those are not moved to the dataset, the final dataset which we create. Since end of file is not reached, iteration 3 next completed the same way. Okay. Various steps, we have already followed these. Okay. So in all, these data set or while creating various data sets, we have already covered the following scenarios like creating data set from existing SAS data set, copying entire data set, changing order of variable, or keep drop. Similarly, the combination of length and keep drop will work, with the length first creating the variable and keep and drop being applied, right? So the major task of today, what we covered was to see that how input buffer, PDB are working, and then we saw that how misover is being used. Misover is also a very important command. Similarly, we have other similarly misover, we have other commands as well. So we'll be looking at them as well in later on in later sessions. But we saw that how to create data set from existing data set, and then we saw that how to create data set from raw file, right? If you have any questions, just let me know, or I'll be sending this slide. You can go through it and have a detailed go through on it. So that's all for today. Thank you so much. Bye bye.